gears a little bit. We talked about security. We talked about the challenges that come from the hardware up towards us. Let's go the other way. Let's look at user space. And of course, the last few weeks, a lot of people who care about security have learned a lot about XZ and about the pretty amazing, and amazing in a bad way, very long planned and well executed attack on the ecosystem. And I'm curious what your thoughts are about this.
Well, so I'm hoping people know the background. I'm not going to go very much into that, where open source in many ways relies on a certain amount of trust, where you trust the developers, you trust your co-maintainer, you trust the people around you to do the right thing. And honestly, it's not true just in open source. I mean, it's true even in proprietary source. You depend on the trust in the company, but also within the company, you depend on trusting your employees. And that trust can be violated. And how to figure out when it's been violated is an open problem. And we've seen this before. In the kernel space, we actually saw a university several years ago that tried to do a study on how easy it is to upstream bad kernel patches. And that's actually an interesting study. They just didn't do it very well, and they didn't tell a third party about this, and they just send us bad patches. Understandably, maintainers A caught the bad patches, and B were really upset about this, and were going, hey, you're a university group, and we were kind of trusting you, and you broke that trust. And that really ends up being a very personal matter. We had maintainers who were very pissed off.
Well, you were being experimented on. You were the objects of an experiment, and that is in violation of a ton of ethics rules.
Yes.
You can't do that.
Yes. But I mean, so we've both seen that kind of experiments, and now, not in the kernel space, but in another open source project, we've seen an actual malicious attack. And nobody really had any explicit gates in place to try to catch this. But what I actually see as a huge positive is that despite there not being any explicit rules in place, let's try to catch malicious activity, in both cases, they were actually really caught fairly quickly. Yeah. So the XZ attack had a history going back several years, but when the actual bad actor took advantage of becoming a maintainer, it was found within weeks. It was pretty quickly.
But it was found randomly?
It was found randomly. But my point is, random ends up being good. I mean, you can't always have specific rules in place, because it's kind of, when you have rules in place, the bad actors, they don't follow the rules. So they can try to work around whatever technical rules you have in place. And the fact that open source projects have found these kinds of attacks does seem to imply a fairly strong amount of stability, and that these things do get caught. Yeah. So clearly it's a wake-up call. There's no question about that, and there are a lot of people who are looking into various measures of trust in the kernel. I mean, there are existing projects, PGP being one of the really classic one, which has this notion of a network of trust. And in the kernel, we actually use that amongst maintainers. But I think we're going to see a lot of work being put into some kind of trust model where people see, oh, this is a new person, or this is a person that is acting differently from before.
Yeah, for no particular reason, I want to point out the engineer who found this was a German engineer, but it's just random. Thank you. There's another German in the audience. But I think what's so interesting about this whole notion of trust is, in the after-the-fact analysis of these personas that were the bad actors, of course, they had none of the typical footprint that a real person would have. So Brian Krebs had this interesting piece that he said, the email address used for these attacks never showed up in any of the data breaches, any of the many Equifax, United Health, name any company, T-Mobile, anybody who has their data stolen. And all these email addresses are online. You can find them in databases. And the emails of these bad actors weren't in that data, which is an interesting way to define whether you're a real person or not. But, right? But, so the Linux network of trust, one of the requirements for the signature is that you meet the person face to face and you are supposed to look at their government ID. Of course, a nation-state aggressor can create a false government ID, but still there is an additional level of difficulty. But to me, I think the biggest defense against all that is a healthy community.
Yes.
And the Linux kernel has this incredibly big, but also incredibly deeply entwined and connected community where there are multi-year, multi-decade relationships at the core of all.
Well, it is, that is true. At the same time, it is worth really pointing out how unusual the kernel is as an open source project. A lot of open source projects, even very central ones, are basically run by 1 or 2 or 3 people. And they may have many more people who occasionally contribute, but most open source projects are really fairly small. And the kernel having like just the number of main maintainers, depending on how you count, is between 50 and maybe 150. But we have 1,000 people that basically participate in every single release every couple of months. What we do is not necessarily something that can translate to 99% of all the open source projects.